how much people are looking forward to this session. And it's always one of the ones that people kind of rate the highest because it's a lot of fun, it's more creative. And I think everybody finds something of value because a fundamental part of all of our work is creating visualizations and communicating our science, which is the theme for the week. So the intent of this talk was to position visualization in your workflow, and to think about visualization as not something that you do as the end product of the science that you're doing. You don't do a bunch of science and then do some visualizations at the end and publish them. You should be doing visualizations throughout your work as a way to frame and think about your science and gain insights into the data or the theory or whatever it is that you're working with. So we're going to start with a little bit of background and then transition into some history. I'll discuss kind of the dominant, I think, perspective, especially among professional astronomers, on good visualization practices. And then I'll sort of close out with some more modern perspectives and kind of a broader view of the landscape of visualization and scientific communication. So these are the kinds of resources that I've found meaningful in learning about visualization. So the big one is this book by Tufte. So this will be framing a lot of the talk. There's this book by Tukey it's like a standard reference that people always go back to. This one is a little bit more recent, and then I really like especially these books by Alberto Cairo. So he's kind of one of the main people. He's very famous for doing like Scientific American, like you open it and get the 2-page graphics and things like that. And then when I was preparing this, and the lecture is based on this book, Data Sketches, which discusses some modern visualization practices. And this is just a giant book of really cool data visualizations and also reflections on the process that led to them. So talking about different concepts that were rejected, why they were rejected, what was tried, what worked, what didn't work, that sort of thing. So if you want to get into serious visualization, I think this is a really good book to think about how you actually do it, and a really good place to go for inspiration. So starting with Tufte, the kind of received wisdom about visualization, the most important principle is to show the data. And a lot of Tufte's book is really written to make this sort of ethical claim that the most important thing for you to be doing is to be giving a truthful representation. And the best way to do that is to actually show things. If you are leaving information out that is relevant for someone to know or to grasp from your visualization, you are not being truthful in your representation. And when Tufte was writing, people were doing a lot of this. A lot of the common faux pas that you may have heard about, things like cutting off the axes to show a limited range. A lot of these things were happening, they still happen today, but they were happening far more often when Tufte was writing. And so this was kind of the key point, and I think the point that that people really took away and also connect with the other kind of principles. So I'll put those in. So there's some other principles, right? And these are all important. But first thing is to always make truthful visualizations. Then you want your visualizations to be substantive. You want to respect your viewer, your reader, the person that you're communicating with, and not have a visualization that isn't making a point that matters. You want to avoid distractions. We'll talk about how to do that, some common mistakes that people make in distracting in the creation of their visualization. This is hard, right? You want to make large data sets coherent, right? We'll talk about how to do that, but that's obviously going to be a big challenge for modern scientific experiments and modern scientific workflows. You want to encourage comparisons, right? You're communicating something. Just showing some random data without any context is not doing anything to communicate. So you want to facilitate people's ability to interpret data in your visualizations. And you want, again, this is about coherency, clarity of communication. You want to have a clear purpose in every visualization. So why do we use graphics? Why don't we just list some summary statistics? So I'm going to put up some data sets in a second, but all of these have the same first order statistical properties. These are not the same data set, right? So I can fit the same line, I can quantify the data, and I'll think that I'm looking at the same data set, but these all have very different structures. They might correspond to very different physical processes or something. And if you think this is a contrived example, I have another one to show you, which is this guy. So this is the data source. The data source also has the same statistics as all of these distributions. And if you click on this plot in the slides that I'll provide, it will take you to a website that will allow you to make more of these kinds of interesting data visualizations, right? The point here is that you should be visualizing your data. If you're just looking at summary statistics, you could miss a lot of the meaning in the structure of your data. So where did visualization start? So I don't think this is the first data visualization, but I think it's a nice touch point. So this is a visualization from Babylon in the 6th century BCE. This is a map of the world. And so if you look closely on this, and again, these are all clickable when you have the slides, so you can go read the British Museum's take on this artifact. But this is basically a map of the Euphrates River and surroundings. And in this map, the world is surrounded by water on the boundary. This is also a map of the world. In this case, this is from China, quite a bit later. This is also an early example, right? So early data visualizations were a lot of times about depicting the universe, allowing people to navigate and interpret their place. So this is quite a bit later, but this is a very interesting one. This is also a map of the world. By this point, people's knowledge of geography had maybe not improved, but had expanded. And so this is visualizing wind currents, right? And again, this is a very practical visualization because the intent here was to communicate, if I want to travel from Europe to Africa, how do I do that, right? I need to know the wind patterns. And this is one of the earliest examples of not just visualizing spatial locations, but plotting some abstract quantity on a spatial visualization. So starting to link abstract notions with the physical world. Another kind of visualization that has very old roots is time series. So this is a plot from the Middle Ages about the inclinations of the planetary orbits. It was pointed out when I was reviewing these slides that this is completely wrong. So the data here, it's not at all clear where this data came from, but these are not correct at all. And I think this one, especially, this is the sun. If the sun's inclination in the sky was changing this much, there would be problems. I think it's also really important to point out that visualization is not a European exclusive tradition, right? So this is a American Indian visualization. This is called the winter count. So in this culture, the yearly cycle was every time first snowfall happened. That was when they would say sort of a year or an equivalent of a year had passed. And at that time, the leaders of this group would get together and they would decide on a pictogram to represent that year or an important event in that year. And that would be put on a hide. And so these would be stored and transmitted as a way of maintaining a history of this people. And again, this is linkable. This goes to a nice PDF that goes through the history of this. And this is in the Museum of the American Indian in Washington, DC. A really fantastic museum. Highly recommend that you visit if you're ever there. Some more time series. So in the kind of canonical lineage of visualization, this one comes up. So this is a visualization from 1786. People were starting to develop a rigorous notion of economics. And so what people were trying to do is plot imports versus exports. So this is not only an example of a time series, a more abstract kind of visualization, but also this plot has a message, right? This is trying to convince you that there's something important in the balance against England versus the balance in favor of England. So right when you look at this visualization, you're being told something about the wisdom of imports and exports, right? Whether that's true or not, not going to comment, but I think it's important that this is maybe not a truthful visualization. This is someone is trying to communicate a specific message coming from a specific point of view to you. This is here as one of the first kind of bar charts that gets brought up. And it's kind of intended here to contrast, right? So there's more information here in the time series. In this case, there was less temporal information available. So our bar chart ended up being the visualization that was selected. And we'll talk a little bit about what kinds of visualizations are good, which ones you can look at and abstract information from easily or with more difficulty. I like this time series. It's very complicated to actually read off. There's a lot of noise here. Talk about that again in a second. But this is a plot of, this is basically the Paris train schedule from 1885. And so the way you read this is you pick a starting time from Paris, and then as you go down, this will give you the time that the train arrives in different cities. So probably the most famous data visualization of all time is this plot, and this is a very kind of abstract thing, and it also communicates a message. So this is a plot of the size of Napoleon's army on his march to Moscow. And so what you see is that as Napoleon marches to Moscow, so it's kind of time on this axis and distance, his army gets progressively smaller and smaller and smaller, and only a small fraction returns, right? And so the idea here is that you can abstract something about this military campaign and, you know, its wisdom or lack thereof. And again, this is historically notable because it's plotting something very abstract. It's a very sophisticated visualization, right? There's both time and spatial information and something abstract like a number of soldiers in an army that's being plotted here. So I thought there was something kind of deeply significant about this. So if we look back to sort of the beginning of data visualizations history, we're looking at visualizations of the world. So what are we doing with LSST? We are making a visualization of the world, right? We are engaged in this kind of tradition of trying to understand our place in the cosmos. Our visualizations just look different. We plot distributions of galaxies as a function of angle and some abstract quantity called redshift, but we're still engaged in this kind of spatial map-making visualization as a core part of a lot of the work that we do as astronomers. Okay. So one thing that you can look at is thinking about the sophistication of your graphs, right? So part of the history of data visualization is increasingly plotting more abstract, more relational things, moving from spatial and temporal visualizations into comparisons between different abstract quantities. So this is one of the first sort of pie and line charts. And so these things are being combined here. And the point with this figure is that as sort of one of the first kind of relational pie chart sort of visualizations, it's already hard to interpret. And the reason for this is that it's hard for humans to sort of judge relative areas. And so pie charts are already kind of an unsuccessful thing. But it was one of the first things that people tried to visualize relational data. A more successful idea is, yeah.
Would you mind defining what you mean by abstract in this context? Is there an abstract?
So like if you think about like early visualizations were always like where something is when it's happening. An abstract thing would be like this plot here, right? How much did the English make versus how much did they export? How much did they export versus how much they imported? Something that's not like a physical quantity, that's not about navigating or this sort of a thing, right? It's things that are, yeah, maybe abstract's the wrong word, but it's moving from these kinds of spatial visualizations into quantifying the world and plotting relationships between different ways that we quantify the world. So this is a better relational graph, right? So, and maybe this was a better example to just jump to, right? Is the smoking death rate in 1 year versus the smoking death rate in another year. And actually, I think when I originally put together these slides, I had some kind of deep insight to draw from this. And I think actually that, you know, maybe this isn't a great example of a relation, two relational quantities, right? Maybe there really isn't a message here. The scatter is really large, doesn't seem like a line fits this really well. And this plot, which is another representation of the same data, right? So this is plotting number of deaths in smoking from smoking in 1990 versus in 2019. And basically, if you look at the actual points, when you plot two numbers like populations against each other, you're just plotting the population of the countries that the data is taken from, right? So even though this is a better way to sort of look at relationships between two quantities, you have to be careful about the quantity that you actually plot. So something like death rate probably is some information here. It's just not well captured by a linear relationship. Whereas something like raw numbers, you have to make sure and adjust for things like the population that you're studying. Tufte gives a couple of kind of general principles. I don't know that these are often used in a like quantitative way, but you can think about the sophistication of your graphics is being captured by the data to ink ratio, which is how much of the ink in your graphic is data versus other things like coordinate axes or other kinds of markers. And the data density, which is the same quantity, except instead of the ink, it's the area of the graphic. And Tufte says you want both of these to be as close to 1 as possible. You don't want any part of your graphic to be extraneous or extra. That's just going to distract somebody from getting the message. And then Tufte also says the complexity is of your entire sort of visualization or set of visualization is captured by the percentage of the graphics that are relational, that are measuring relationships between 2 abstract quantities. Okay, so these are a couple of quotes. So above all else, show the data, maximize the data ink ratio and the data density. And you do that by erasing things that are not contributing to that ratio. And then sort of a general principle that comes up when you have extraneous things is be careful that you're not creating optical illusions in your paper. So as Tufte says, graphics are reasoning tools, they're not art. That may or may not be true. So this is the received wisdom that visualization starts from, but there are more modern perspectives that maybe add some caveats to this claim. So I think this is a good place to start. It's something you want to keep in mind, that your graphics are reasoning tools that you use throughout your workflow. But we are going to add some caveats in a second. So speaking of unintentional optical art, so it's really easy to create vibrations, weird distortions by putting lines next to each other. So these are just 2 examples of common things. But what you want to do is when you've created this sufficiently sophisticated visualization, is you want to look at your visualization and be on the lookout for optical illusions that you maybe didn't intend, but will distract somebody who's trying to view and interpret the message that you're trying to communicate. We can put Tufte's principles into practice. So this is just some random data set and made with a kind of maybe some strange choices in Matplotlib, but there's a lot of extra stuff going on here. There's a really nice package that will take figures like this and we'll make them in the Tufte style using his principles. So I've just recreated that data set there. And again, you can sort of click on this and it will take you to the code that makes this plot. But the idea here is that we're going to eliminate these extraneous grid lines. The information that's communicated by the grid lines can be captured by adding sort of a blank space in the bars to indicate gradations. We don't really need the axes at all. Our Y and X labels should have communicate something. So maybe categories and percentages, as opposed to some numerical scheme and some kind of random values, right? So these are the things you want to think about, right? Eliminating extra stuff and making everything in your plot communicate something. So yeah, another example. I don't 100% love this, but Tufte likes this idea of your axes should only cover the range of your data. So basically eliminating, you could imagine that these axes go to 0 here. So he sort of truncates these axes. But this is one example in Tufte's book that that comes up as a way to eliminate kind of some extraneous things. And there probably are settings where eliminating some extraneous axes, markings, and these kinds of things can help your visualization. Okay. So one other thing that's nice to do is to use redundancy. So this is a nice visualization that does a lot of these things. So this is, so I believe this is fraction of different countries' economies, fraction of government spending or government receipts as a function of the size of the economy. So it's a percentage. How much of GDP is the government spending? And so there's redundancy in this visualization. So listing all of these on both sides. And so the relative spacing tells you something about how that number has changed. But by adding a line, you've added an extra way for people to tell that relationship, which is really nice in the more complicated regions of the space where maybe telling the relative ordering is hard. And so you can look and say, oh, Britain went down, but maybe I would have been confused if I just tried to read that off. And so you can use redundancy to do that. Okay. So that, again, is the kind of received wisdom. Do folks have questions about that kind of framing before we move on to some slightly more modern perspectives.
I feel like the idea of like using redundancy as an effective tool is something that you need practice with, because it feels like conventional wisdom is be as simple as possible, be as clean as possible, and redundancy feels kind of like the opposite of that, but it also doesn't feel like it's conflicting with the stuff you said earlier about like the ink to space ratio and all of these things.
Yeah, I mean, and that was kind of gonna be my response. So I think that's a good reflection, right? But I think this is a nice example. There's not a lot that's extraneous here. And since you've removed a lot of the other kinds of extraneous things that could be here, you now have more space to add in a redundant part of your visualization that will aid people in interpreting rather than distracting them with something that is not relevant to the point that's being made. You have a
Yeah, another quick thought that I'll add is that every time you're building, say, a talk which has many visualizations, or a figure that typically is one of many, we rarely write papers that are only a single figure. Part of what you are also doing is training your audience to understand you, and redundancy can be extremely powerful in that regard. So I will talk a little bit about this later this week, but you can imagine, right, if you're giving a visual presentation and your first slide, the title's on the left, your second slide, the title's centered, your next slide, you wanted to get funky and you put a little diagonal in your title, right? Your audience isn't going to know because you're not training them where it is they go to get the information that they need. And so if you think about visual elements as something where you can basically build in a code and you can teach people as you're going, this is another way that redundancy can be very powerful.
Any other questions about the Tufte perspective?
This is opinion on using color in plots, because one thing I'm noticing is the plots look very neutral and that everything is one color or like grayscale.
Yeah, so I think the kind of canonical statement of Tufte's views was published before color printing was especially like very common and people were looking at things on screens. So that's, I think, part of the reason for the kind of monochromicity of some of the plots. We'll talk about color and how to use it effectively, not just in this talk, but throughout the week.
Say that another reason, a lot of the talks that I attend, when they try to visualize things, they try to keep things relatively neutral in the purple yellow kind of categories, because that there is also a significant percentage of population that has red green color blindness, and that helps with visualizing.
Yeah, we'll talk about that also in
That you're working.
Yeah, we'll talk about that also in just a few minutes. Yeah, color is complicated for a lot of reasons. Okay, so the idea of the kind of maybe slightly more modern perspective is that we want visualizations that both communicate and allow us to discover things, right? So in the kind of Tufte view of the world, you are communicating something as the expert, and visualization is not an interactive, it's not a two-way street. More modern visualizations, as we have like web technologies where you're interacting with data in much more dynamic ways, emphasize the person who is doing the visualization. Or sorry, who is interpreting the visualization. So Alberto Cairo defines kind of visualization as any kind of visual representation that creates communication, analysis, and discovery. This is different from like an infographic, which is something that is meant to represent information that is intended to communicate a specific message. So you could have like an infographic that's like carbon dioxide emissions, and the message you're trying to communicate is we're emitting a lot, maybe it's changing in interesting ways, but we should be worried about it. Or maybe if you're slightly less scrupulous, maybe we shouldn't be worried about it, right? But the point here is that you have a message that you're trying to convey in a dynamic and interesting way, and that's an infographic. A data visualization is a visualization that enables analysis, exploration, and discovery specifically with data, right? So there are visualizations, as we saw, that aren't data visualizations. That'd be something like, maybe in an abstract way, it's a data visualization. That'd be something like the pictograms depicting the last year of history, right? That's a visualization, it's communicating something, but at least in a scientific kind of astronomical context, maybe we wouldn't say that's data. I think there's a valid perspective that that is data, but that's kind of maybe the distinction you could draw here between visualization in general and data. So infographics are about communication, data visualization is about discovery. So with that in mind, when you're designing a visualization, think about what you want to enable. What kinds of analysis do you want people to be able to do? What kinds of comparisons should they be doing when they look at the visualization? And what you're aiming at is spontaneous insights, right? You want people to look at a plot or a figure or something that you've made and have that eureka moment that inspires them to be interested in what you're doing or gives them a new insight, allows them to take actions based on what you're communicating. And this is really about the fact that complicated discoveries are an accumulation of knowledge. And this is where the interactive visualization and the need to have more sophisticated frameworks really comes in. So in a single static visualization, you're communicating something, you're giving people that one moment of insight, whereas in a dynamic or interactive visualization, you're allowing people to explore and take different perspectives that they build out of a bunch of, maybe static or single visualization. Again, this goes to truth, right? Remember that visualizations are models, right? We're making decisions about how we're going to capture a complicated reality that I can't put on a page or put in a figure in a paper or whatever. Okay, so think about the tasks that you want to enable. Start out by trying a bunch of different graphical forms, seeing what works, what doesn't. Spend some time moving things around, right? Give different options once you've selected a different graphical form. Try different things that you plot, different quantities, this sort of thing. And then go back to the beginning, test alternatives. Don't start saying, I know what visualization is going to be meaningful here. Give yourself options to figure out which one is communicating effectively, enabling the kind of analysis, or that enabled you to make a discovery when you were originally doing it. So we'll, in just a second, I'll touch on these two things. There's a kind of nice data visualization catalog that gives you all the different plots that you have available to you. And then we'll talk about the kind of elementary perceptual tasks and which ones are, what order you want to employ, different ways that people perceive the world. So this is just, this is actually now a year or two old, but this is an example from my own work, right? So we started out with histograms of redshifts, it counts as redshifts, and then we tried these kinds of photo Z versus true Z plots, trying to look for insights. We color coded them in some scheme, we broke them up by different survey combinations, right? So these were early visualizations. We then tried some more complicated things. So now we're using these color plots as opposed to like some summary statistic, but we're now plotting summary statistics as colors. Again, we're looking for structure. This didn't seem to work very well. So we tried some histograms or some more histograms, but these ones broken out into specific categories. And what we ended up with are these very abstract plots, which are histograms of an information measure. So a very abstract quantity. But these ones are not the prettiest visualizations, but if you look at them and you know what is being plotted here, you can enable comparisons, right? I can say, in some sense, the combination of different surveys, is this green blob, is different from the blue blob, right? So there's a comparison, there's a relational aspect that maybe isn't captured by, say, this histogram or these color plots, right? The point here is not that this is good work. This is work from a year ago. The paper that actually does this is now on the archive if you want to read it. But this was early visualizations as we were figuring things out, right? So we started from a place of histograms and true Z versus photo Z plots, and we ended with something that's abstract in relation. And then we made it pretty when we actually published. So there's a lot of different kinds of visualizations. I really like this this really nice kind of infographic that you can post on your wall. But basically, if you're trying to illustrate part to whole relationships, you'll use something like a heat map or a pie chart. We've already discussed why pie charts are kind of problematic. Trends and relationships are going to be scatter plots. I think that's kind of the go-to for most scientists. And distributions will be things like histograms or box plots that sort of show the quantiles of the distribution. And then graphs, which show very complicated and very abstract relations for things like flows and hierarchies. For more complicated visualizations, you have, when you're doing this with modern software, you have access to a lot of different tools, right? So you can do 2D things, you can do lines with different styles, you can start to put together shapes, or you can make 3D objects, right? So you should think about, in what context do you want 3D objects? If you're doing a 2D scatter plot, you probably don't want the data points to all be like 3D cube things, right? Like, it's not communicating anything. That's just adding complexity without facilitating communication or analysis. But there may be contexts where you really want to have some complicated 3D object that you want to manipulate. This is really nice. And again, there's going to be a link here. I think Aaron might talk about this in his talk later this week too. But when you are plotting a lot of different quantities, like on a scatter plot, and trying to enable comparisons, you should think about which shapes have strong visual boundaries when they're overlaid on each other. So this is a nice list of the different shape options that you have, and which ones have strong and weak visual boundaries, given that they might overlap. And this is another example of this. So yeah, so this is another example of kind of hierarchies using color and visualization. And I'm pretty sure, again, Aaron will talk about this later in the week. There's also a nice link to this. This is a Nature paper that goes through this and has good wisdom. As was mentioned, there are so some perceptual tasks are easier for the brain than others. So it turns out that sort of color is complicated because we don't judge color differences really well. So this is sort of a harder perceptual task if you want to use color to highlight differences. Position, especially when you give some reference for positions, people can judge that really well. There are a bunch of different things sort of in the middle. So it turns out that, I think this is Q, is people are much better at judging kind of brightness than they are the shade. So if you use a single color, that's slightly better. Areas and volumes are really hard, right? I think especially volume is something that if you look at like a 3D graphic representation of a volume, that's really hard for you to judge the relative size of things. But area is also hard, and that's why pie charts are not the greatest. The other reason why pie charts are not the greatest is that angles are also hard to judge. So pie charts are taking two difficult perceptual tasks and asking you to do them on top of whatever message is trying to be. So as much as possible, stick with kind of positional encodings of data and only resort to these things if you have to. Here's an example of that. This is the same data. Because of the shapes of these curves, the gap between those curves is supposedly the same. But humans are attuned to judging. Yeah. So humans are attuned. This has to do with humans are attuned to judging small differences. So it's something like I think it's the relative gap is the same, is what it is, something like that. But it's humans are attuned to judging small differences or seeing small differences more than they are big differences. So it changes how you perceive the difference between the two curves. And then the same here is this is, I think, a representation of the same data as areas. And the visual impact of those areas is really different. Okay, color theory. So yeah, so as much as possible, when you're using colors, you want to pick colors that are that are communicating something, right? So there are colors that communicate analogies. There are colors that communicate are considered complementary colors that go together. And there are colors that sort of contrast with each other. So you can sort of use a color wheel and look up these color relationships to try and figure out which colors you want to use to do encodings. One thing that you should be really careful though, is that colors have a strong cultural associations, and those cultural associations can often communicate opposite things of what you intended to communicate. So so warm colors are generally considered kind of energizing, passionate, and positive. And in the West, we think of like red things as indicating danger, right? But in Asian cultural contexts, red is a color that's associated with prosperity, right? So it's kind of a desirable thing. So if you're using that in a visualization, danger and prosperity are kind of opposing concepts. You should be careful with that. Green and purple are in the West considered nature colors, renewal, peace, sometimes have religious connotations. In the East, these are political colors. Neutral colors are slightly less problematic because they're often sort of accents and backgrounds. But there is a really big one, right? In the West, a neutral color is about purity or cleanliness. In the East, this is often a set of colors that's associated with death and mourning. So if you're not careful, your color choice can communicate contradictory messages. This is an example that I really like. So, red and green, at least in the United States, and I think in Europe, are colors that are associated with Christmas. So this was the White House Christmas decorations. I think it was very controversial, but it illustrates the point of red and green are very strongly Christmas colors. Red and green are not Christmas colors everywhere. Red and green are strongly political colors in certain parts of the world, right? And you can sort of see from this color distribution that this is reflecting sort of different cultural backgrounds, right? When you're designing, and I should probably have changed this. I don't like this phrasing of designing for the visually impaired. Disability is a social construct. Somebody who's colorblind doesn't have an impairment. They just perceive the world in a different way from a larger part of the population. But you can sort of, there's a nice website, coolers.io, that will allow you to pick a color scheme and select all the different kinds of color blindness to see how your color scheme comes up. And so you can test your choices to make sure that colorblind people are able to interact with your graphics. And the fraction of colorblind people, I forget exactly what the statistic is, but it's actually very large. I think especially for red-green color blindness, it's maybe 5 to 10% of the population. So you really need, yeah.
I know on Mac, I also have an app that's called Sim Dolphism.
Oh,
And
fantastic.
it's actually like this really cool filter, and you can put it like overlay it over your entire screen, and it gives you different filter options for the different types of the color disparity. So you can actually like change and cycle through them to see how your plot colors display
That is
in real time.
That is super awesome.
Very handy.
Especially if you're doing more complicated
Yeah.
visualizations, complicated software. Can
Yeah.
you put that in the Slack?
Yeah.
Yeah,
This is tool called I Want Hue.
okay.
Like how many colors you want to use, and then you like different selections, what criteria is colorblind friendly, it'll give you like 10 different hex IDs or hex numbers, and stuff like that, like visualized data sets. Unbelievably helpful for big colors.
Awesome. Put it in the Slack. Okay. So we've gotten a little bit of a more modern perspective on visualization. And so I want to talk a little bit about interactive visualization paradigms. The idea here is that that just because something is really nice to look at doesn't mean that it's not functional, right? So Tufte's point of view was that things should be very kind of utilitarian, and he gave some good arguments for this. But there were also some good arguments that our visualizations should be fun and interesting and spark curiosity. They should be an attention and an invitation to explore. And that beauty and fun are kind of fundamental values that are just as good as enabling insights or communicating. So let me show you this one. Take just a second to swap over. Oh, okay, cool. So this is the figures in the sky visualization.
Hey, Brian.
Yeah.
For some reason, this is no longer showing up on.
Yeah, I have to swap the. Okay. Good now.
Yes, great.
All right, so this is the figures in the sky. So I think this one is actually covered in the data sketches book if you want to learn about how it was conceptualized. But the idea is that we all see the same sky, but different cultures have interpreted and given different meanings to the structures that are in the sky. So this is a visualization that allows you to explore this. So as you scroll down, so you can sort of pick a star, and you can click on this and bring up. Oh, maybe it's not this one. Yeah, so you pick a star, and then you can pick different representations, right? Different meanings that have been assigned to the star in terms of constellations that people have named. And so this is a really nice visualization that allows you to explore not only astronomy, but different cultural aspects of astronomy and how these two things connect. So there's kind of, the way this visualization is laid out is that stars that are well known, like Sirius and Betelgeuse, are sort of the first ones, but as you scroll down, there's an invitation and there's a large catalog that you can click through and look at a bunch of other ones. So the person that made this created sort of a hierarchy of ones that would be the most inviting for someone who maybe doesn't have a catalog of star names in their head, but also allows you to sort of explore and have some depth to this visual. Yeah, and there's some other sorts of visualizations that are a little more technical, a little more relational, and sort of go through this different cultures that were used for this, some information about those cultures, right? The point here is that this visualization is not a single static graphic that communicates a single point. This is a visualization that you interact with and that you abstract meaning from. So the person who made this is giving you a lot of different resources and a lot of different paths through the data visualization. Go back to this back. Back. Sorry about the delay in task switching. I'm going to do that one more time, hopefully better instant. So the idea here is that these kinds of interactive visualizations are exploiting what we now know about the human attention span. Looking at a bunch of figures like Tufte makes is a really static, it's not a very interesting experience, right? And as a communicator, what I'm doing is I'm trying to build this thing up, and attention is draining away the information I'm trying to communicate. So interactive visualizations, dynamic visualizations, interesting visualizations, ones that are beautiful, allow people to retain more of what they're communicating. And so all this extra stuff that Tufte was kind of railing against, it actually can serve a purpose, right? You still want to maintain those principles in the back of your mind, but you also want to make things that look nice, that are pleasant, that encourage people to spend more time with your data. I'll give you a second. So. Did this not work for anybody? Yeah. How did you read this?
I read the biggest text and then I went to the top and read down.
Okay, yeah, so that's another hierarchy, right? Reading from the top down. Was that also what you did, Daniel?
I did biggest, then Andrew read this, then Andrew read this. I just put the last two.
Okay. Interesting, yeah.
I think it's like order font size and then top to bottom.
Yeah.
Those two are the same one.
So I'm not going to say much more about this other than that this works, right? Adam is going to talk about this in his talk on Thursday. Okay. So yeah, I think maybe I'll just post this in the Slack, just because I can sort of see that people's attention is waning. But this is also a really nice interactive visualization. This one is communicating how machine learning is done specifically. And so there's kind of an invitation over here, some abstract graphics that I don't maybe know exactly how to interpret, but it sure looks cool. And then there's a specific instruction for what you're going to do, right? You're going to scroll down. And as you scroll down on this page, these visualizations dynamically move and rearrange themselves into different representations of the data that enable certain different comparisons. And so this visualization is a summary of a specific project. I think this is, yeah. So this is housing data from New York versus San Francisco. And so a lot of the point of this visualization is to enable different kinds of comparisons. And so, yeah, so this data rearranges itself in different ways, right? And it tells a story about the analysis that was done, how it was done, and creates a narrative that you have the ability to sort of critically evaluate as you go through this dynamic visualization. So there's a bunch of different paradigms. I'm just going to highlight a couple. So one is like a point and click paradigm. So, if I plot some data, I can click things, I can move a slider that will change the date range, things like that. So that's one paradigm. One that I find very useful is this point and drag, right? So if I want to examine some smaller data range, maybe I can click on this visualization, select a region, and only look at that region. So these are kinds of common paradigms of interactive visualization. A nice one, I think somebody did a hack project at the last visualization session on trying to do something like this, is like a drag and drop thing. So like, what if I could grab the data and make a separate plot, or I could grab some data from somewhere else and drag it onto the plot, right? Yeah, so these are some, so this one that I showed was by Tony Chu. And these were some of the principles that he talks about how to make these kinds of things. So as I mentioned, kind of smooth transitions, this data cloud moves on its own into different, as you scroll down, moves on its own into different kinds of plots. And then also there's kind of extra visual channels. So as we talked about, there's different perceptual tasks from color, different relationships, these kinds of things. And as you sort of animate things, you move through those perceptual tasks to let people find the ones that work for them. Okay, so this is a nice kind of concluding question for this talk that I'll give you all maybe like 2 minutes to talk about. And I feel like I've biased it because I've sort of already said this, but is this what Tufte would call chart junk? Why or why not, right? And feel free to disagree with the kind of narrative that I've crafted for you. So take 2 minutes and talk to the people next to you about that. Take 2 minutes and say words about yes.
Sorry, are you referring to the idea of like phosphate harness and the previous
Yeah.
class for this question? Okay.
Yeah, so the whole last 10 minutes or so.
Okay,
Yeah.
Okay, I was waiting for it.
Looking at the lines.
Is the blank slide chart junk, or just does it not communicate anything?
Great representation about the amount of data we have to be talking about.
A first person experience with writer's block.
Why do I care what Toby thinks?
That was my point, like, I know what you said, they're not the way we get fit, it's the, like, a first thing that would really be listening.
Yeah.
His views were really revolutionary when he wrote them, and they've been very influential. I think there's a lot of wisdom in it, but I think it's the standard kind of view that a lot of people, when people know of Tufte versus where modern visualization is, I think there's a big gap between those, and I think there's a lot of value in the modern perspective. It's worth reading Tufte's that I would say. Whether you internalize that and make that your life's mission. Let's take 30 more seconds. Okay, so let's come back together and let's share some reflections about what we think of modern visualization paradigms. So does anyone have a strong feeling about whether these kinds of things are distracting or chart junk?
What I think is, no, this is not chart junk because of one simple reason is that we are all early career astronomers and we're going to be going for a lot of conferences throughout our careers in different parts of the world, which means that they're going to have different kinds of representation and visualization for all sorts of data. And something that I saw from one of the other IAU symposiums that happened last year that happened in Japan, that they work and they represent stuff completely different. So, getting exposure to different kinds of visualization is really helpful for, when you eventually do find yourself in a situation.
Yeah, I love that. I hadn't even thought about that. That it's not just giving people different kinds of perceptual tasks, it's also giving a visualization that maybe reflects what it's always complicated, but what you know of their culture or what you can put of your culture into the representation of that visualization and giving people options to modify that. Which also goes to making things open source, making your plotting code available so people can change it if they need to. I didn't mention it, but that's something with my most recent paper, we had to plot a large number of curves, and there's a kind of color blindness that we couldn't find a color scheme that would address. And that kind of color blindness is pretty rare. It's like 0.1% of the population or 0.01% of the population. But we're making our plotting code available so that people with that can go in and change the color scheme so that it works for them. Because we couldn't find one that works for every kind of color blindness. So yeah. Did you? Yeah, sorry, I thought you were raising your hand.
I was gonna ask.
Yeah.
Speaking of color palettes, is there a suggestion or recommendation or best practice of like if I had two colors on my figure, if I could use these two colors? If I had three, then I could use these three, or is it kind of up to you and like what you want to convey?
So I think my answer is the latter, but I would ask Aaron during his talk, probably this afternoon. Yeah, so his talk is going to be really about the science of perception, and so I think he might have an interesting perspective on that. So yeah, so I said that I didn't think so because it's the context, the additional things are a form of data density. It's not the data itself, but it's conveying information. It's allowing you to make comparisons. Okay, so we are just a few minutes ahead of schedule, but I blocked this talk as an hour, and normally it's better if talks are 45 to 50 minutes. So I think we're okay with that, but I did want to sort of walk through the exercise that we'll do after the break. The idea here is that if you can't make your design work on paper, you're never going to be able to make it work on a computer, right? It's much harder to make things work digitally. So what we're going to do is Adam grabbed some paper and there are some colored pencils, and we are going to have art hour. So we're going to do we're going to focus on these questions. So exploratory data analysis. So what are the questions that we want to encourage? How are we going to design an interactive visualization to test hypotheses about our data? You should sketch out a multi-part visualization, so it has different elements. So I'll give you an example. So when I originally put together this talk, it was right around the launch of JWST. And so this was my first kind of, how do I want to visualize JWST is there's a hierarchy of data, right? There's the data, the actual CCD exposures, that gets converted into some calibrated data, that maybe gets converted into more calibrated data, different kinds of analysis steps. And so I was thinking there's like this web or this hierarchy of different data. So initially I picked as my kind of modality of this visualization, I picked sort of a graphical structure. But I wanted to make this kind of interesting, enable people to explore and have some beauty and whimsy in it. And I thought, wow, the mirror structure for JWST kind of has that hierarchical structure. So can I create a visualization that would be colorful for different data types? And as you click through different data types, maybe that tells you about different science things or different science topics that people are working on. And then maybe you can click through that and that would give you other kinds of representations of the data, or maybe that connects to the papers and analysis, right? So trying to map this hierarchy of the different things that the facility provides us with a representation of that hierarchy that is interesting and allows us to explore relationships. I'm not saying this was a masterful visualization, this is just what I came up with. I really liked the idea of using the mirror structure as a visualization. I'm sure somebody's done some cool stuff with that, but that's just one example. So after the break, you will find a data sketches. The file name is slightly different from this, but you'll be able to pick it out. There's a data sketches notebook, and it will guide you through sketching some concept visualizations with people around you. So that's the exercise, and we'll have fun with it. There's also whiteboards and things like that. Yes, I don't know where the colored pencils went, but we'll have them when you're back. So, yeah. Oh, okay, so I think it's back, the back table then. All right, so yeah, that's it. We're gonna have a break. So let's come back at 11 and we'll have art hour.